It was night on the deck of the USS George H.W. Bush in December 2021, the ocean black. The flight deck was a chaotic maze of lights and shouting. Through the gloom, a yellow shirt, there's an aircraft director for us not up with our Navy slang, waved his wands, signaling an aircraft into position near the catapult. A small tractor drags a strange grey shape forward, and the yellow shirt signaled a turn. On a normal night, you'd see a pilot in the cockpit acknowledge that command with a hand signal or a nod, but on this night, the cockpit was empty. Instead, walking alongside the nose gear, there was a sailor holding what looked suspiciously like a chunky video game controller that was strapped to his chest, his thumb hovering over a joystick. This was a heavy, multi-million-dollar aircraft being maneuvered on a pitching deck surrounded by hundreds of people and expensive hardware, all being controlled by a guy with what looks like an Xbox control. If the machine just decided to accelerate at that moment, maybe pushing the joystick forward, it was about 3 seconds away from punching a hole through the deck crew and rolling off the side of a nuclear-powered warship. But the yellow shirt signaled a stop, and the sailor thumbs the joystick, and the machine halts perfectly on the catapult track. This is the Boeing MQ-25 Stingray. It is the world's first operational carrier-based unmanned aircraft, and on that night, it was proving that it could survive on the most hostile airfield in the world. But despite looking like a futuristic stealth bomber, its job isn't to bomb or dogfight. Its job is a bit boring. It's a flying gas station. Now, you might be wondering why the US Navy is spending billions of dollars to build a robot that just carries fuel, and the answer to that lies in something called the tyranny of distance. You see, in the Pacific Theater, the distances between safe bases and potential combat zones are measured in thousands of kilometers. The Pacific Ocean is really big, yet modern carrier fighters like the F/A-18 Super Hornet and the F-35C actually have shorter combat radiuses than the old Cold War workhorses like the A-6 Intruder. To fix this, the Navy has been forced to use its own fighters as improvised tankers. Currently, somewhere between 20 and 30% of all Super Hornet sorties are just refueling missions. They hang extra fuel tanks on the wings and fly out just to top off their friends. This is kind of like buying a fleet of high-end Ferraris and then using a third of them to deliver Uber Eats. It works, yes, but it is an incredibly stupid use of money and airframe life. The day my Uber Eats driver turns up in a Ferrari, we'd be like, dude, what's up?
It's a perfect time to change jobs.
It burns through the lifespan of your best fighters while also keeping them out of the fight. The MQ-25 is designed to stop that waste by spending billions of dollars. It can launch from the carrier and deliver between 14,000 and 16,000 pounds of fuel to other aircraft 500 nautical miles away. To put that in perspective, that's roughly 2,400 gallons. That's enough gas to fill up about 160 family cars. You're welcome. But if you're a carrier-based drone with that kind of range and internal volume, you don't have to fill it with gas. You could fill it with radar arrays, you could fill it with sensor packages, or one day, you could indeed fill it with stealthy anti-ship missiles. And we'll come back to that later. But for now, let's have a look at how it actually works. The problem. Okay, to understand why the Navy is making a huge bet on a pilotless flying gas station, we first have to look at the massive strategic headache often described as carriers with short arms. Sort of like a T-Rex. If you go back to the Cold War, a US carrier air wing had incredible reach. They launched aircraft like the A-6 Intruder and the S-3 Viking. Rugged, long-legged machines designed to haul heavy payloads over vast distances. They could strike targets hundreds of miles away and loiter for hours, keeping the aircraft carrier itself well out of harm's way. But those aircraft are gone. They were retired years ago, leaving the modern air carrier deck dominated by the F/A-18 Super Hornet and the F-35C. Now, these are fantastic, high-tech, multi-role fighters, but compared to their ancestors, they've got short legs. Their unrefueled combat radius is significantly tighter. Now, this wouldn't be a huge issue if the United States was only fighting insurgencies in places where the enemy has no navy, but the world's changed. Potential adversaries, specifically China, have spent the last 20 years developing long-range anti-ship ballistic missiles. These are weapons designed to hunt carriers, and they can hit targets from well over 1,000 kilometers away. So, here is the problem the Navy is facing. If you put a US carrier in the Philippine Sea and draw a circle representing how far its jets can fly without refueling, there is a very good chance that that circle doesn't even touch the Chinese mainland. But if you draw a circle for the range of China's land-based missiles, it easily encompasses the carrier, which is not brilliant news for the US Navy. The obvious solution here is aerial refueling. If you can gas up the fighters in midair, you can extend their range and the carrier can stay safe. But the Navy doesn't have a dedicated carrier-based tanker anymore. They retired them. So for the last 2 decades, they've been using a bodge solution known as buddy tanking. We're learning a lot of Navy terms today, aren't we? This involves taking a frontline fighter jet, usually a Super Hornet, and strapping a massive external fuel tank and a buddy store refueling pod to it. This pod, often made by Cobham, contains a hose and reel system. The fighter launches, meets up with its mates, unspools the hose, gives away its gas, and then it goes and lands. And on paper, this works. In practice, it is wildly inefficient. According to some analysis, and even the Navy's own data, around 20 to 30% of all Super Hornet sorties are just tanker missions. They aren't dropping bombs, they aren't patrolling for enemies, they're just hauling fuel around. You're essentially taking a $70 million supersonic fighter jet flown by a pilot who has been trained at enormous expense to be the tip of the spear in aerial combat, and like we said, they're essentially a flying fuel truck. Inside the Pentagon, the pressure was mounting. They needed a solution that could solve the range problem, stop wasting Super Hornets, and survive in a high-threat environment. They needed a machine that could fly long distance, stay up there for hours, and didn't need a pilot to complain about flying in circles for 6 hours straight. Not exactly behind enemy lines territory, is it? That necessity birthed a question that would spark a fierce internal battle. If we're going to build a new unmanned aircraft for the carrier, should it be a high-tech stealth bomber that can strike deep into enemy territory, or should it be something boring, unglamorous, but desperately needed? A tanker? Well, the answer to that question would define the future of naval aviation. The drone bomber that almost was. Okay, to understand the Stingray, we have to look at the ghost of the machine that it's replacing. The entire program essentially serves as a sequel to a movie that never got released, a project that promised a stealthy robotic bomber but delivered a flying gas station instead. In the late 90s and early 2000s, the Navy and DARPA began exploring the concept of unmanned combat air vehicles, or UCAVs. This effort culminated in the Northrop Grumman X-47B. Now, if you've ever seen footage of this thing, it looks like it fell straight out of a sci-fi movie. It was a tailless flying wing, like a miniature B-2 bomber, designed to prove that a robot can land on a pitching flight deck. And it absolutely worked. In the early 2010s, the X-47B successfully took off and landed autonomously on a carrier, proving that the concept was viable. From this success, the Navy launched a program called U-Class, Unmanned Carrier-Launched Airborne Surveillance and Strike. The dream was pretty ambitious, a high-end, stealthy, long-range drone that could penetrate deep into enemy airspace, spy on targets, and drop bombs. It was going to be the tip of the spear. But by 2015, the program was stuck in bureaucratic purgatory. Robert O'Rourke, then US Deputy Secretary of Defense, found himself staring at 6 years of circular arguments about what this drone should actually be. According to Work, there were 3 distinct schools of thought fighting for the budget. The first camp wanted a high-end strike aircraft, basically a robotic stealth bomber, to kick down the door of enemy air defenses. The second camp wanted a long-endurance drone optimized for counter-terrorism, something that could orbit for 24 hours over permissive environments, hunting insurgents. The third camp just wanted a surveillance drone to watch the ocean around the carrier. And Work had to make a decision. He asked naval planners a question. What can we afford, and how fast can we get stealth on the deck? The answer disappointed him. Officials told him that developing a new unmanned stealth bomber would actually take longer and cost more than simply buying more manned F-35Cs, which were already coming online. So, Work forced a compromise. The Navy would accelerate the purchase of the F-35C to handle the stealth strike role. Meanwhile, the U-Class drone program would be gutted and repurposed. Instead of a bomber, it would become a tanker, something cheaper and vitally needed to stop the Super Hornets from burning out their airframes on refueling missions. It was a really pragmatic decision. In another timeline, the MQ-25 might have been the world's first autonomous stealth bomber, and we'd be making a much more interesting video for you instead, but thank you for sticking with us. Instead, it was designed to be a utility player. Everyone is disappointed. In 2016, the Navy formally killed U-Class and rebadged the program CBARS, the Carrier-Based Aerial Refueling System. And props again to the US government for coming up with acronyms. The focus shifted entirely to tanking with a little bit of surveillance capability on the side. The Navy officially named the future aircraft the MQ-25 Stingray, the M meaning multi-mission and Q indicating it was unmanned. A competition was launched between the heavyweights, Boeing, Lockheed Martin, and General Atomics. But then, a bit of a surprise. Northrop Grumman, the company that had actually built and flown the X-47B demonstrator, dropped out of the race in 2017. They looked at the requirements and essentially said, this doesn't really make business sense for us. Sorry. When the dust finally settled, the field was clear for a new design. And when the winner was revealed, it wasn't the flying wing stealth jet that everyone had expected. Designing the Stingray. In 2018, the Navy made its decision, awarding the engineering and manufacturing development contract for the MQ-25 to Boeing. This raised a few eyebrows in the defense community. The Navy had explicitly watered down the requirements from a high-end stealth bomber, U-class, to a utilitarian tanker, C-bars. Yet when Boeing unveiled their design, it didn't look like a flying fuel truck. With its blended fuselage, flush air intake that hides the engine fan blades, and a distinct V-tail, the Stingray looks suspiciously like the stealth drone that the Navy said it didn't want. Defense analysts, including those at the war zone, have pointed out lingering questions about the origins of this shape. The strong implication there is that Boeing had already done the heavy lifting on a stealthy U-class design, and rather than just throwing it away, they essentially repurposed it. They gave the Navy a gas station, but they disguised it as half a stealth bomber. To understand the scale of this machine, you've got to look past the sleek renderings. The MQ-25 is a beast. It's 51 feet long, that's roughly the length of a standard city bus. Its wingspan, 75 feet, which is massive for a carrier deck aircraft. To fit into the ship's garage, the hangar deck, the wingtips fold up, which means it's just 31 feet across. Powering this frame is a single Rolls-Royce AE3007N turbofan. This is not some new experimental engine, it is the navalized variant of a workhorse engine used in business jets and the massive MQ-4C Triton surveillance drone. But the only stat that really matters here is the fuel load. The Navy's objective for the Stingray is to offload 14 to 16,000 pounds of fuel at a range of 500 nautical miles. To put that in perspective, that's about 2,400 gallons of jet fuel, and to continue our car analogy, it's 150 family cars worth of gas. Now, regarding that stealth look, it is important to clarify that the MQ-25 is not a broadband stealth aircraft like the B-2 Spirit or the Flying Wing X-47B. It flies with pods hanging under its wings and has a conventional fuselage shape, which compromises its radar cross-section. However, it is low observable. That flush inlet we mentioned is critical because it hides the highly reflective spinning blades of the engine compressor from enemy radar. The V-tail removes the need for a large, reflective vertical fin. The actual tanking part of the drone is surprisingly old school. Under the wing, the MQ-25 carries the Cobb and Buddy Store refueling pod, the exact same hardware used on the Super Hornets today. It uses a hose and drogue system. The drone unreels a hose with a basket on the end, and the receiver pilot plugs their probe into it. There is one fascinating, slightly terrifying detail about this setup. According to the Royal Aeronautical Society, the MQ-25 has no rear-facing camera or proximity sensors dedicated to the refueling basket. It doesn't see you approaching. Just like with a human-flown tanker, the robot flies a steady line, and it relies entirely on the skill of the human pilot in the fighter jet to plug in. It won't babysit you. You still have to fly tight formation with the robot in turbulence, at night, and over the ocean. So how do you control a robot like this? Well, you don't really fly it in the traditional sense. On the carrier, the Stingray is managed via the Unmanned Carrier Aviation Mission Control System, or UMCS. The Navy has even installed a dedicated room aboard the USS George H.W. Bush called the Unmanned Air Warfare Center, or UAWC. Inside, air vehicle operators sit at consoles. They don't have a stick and rudder. Instead, they pre-program the mission with waypoints, refueling tracks, and contingencies. Once the drone launches, it is largely autonomous. It executes the plan on its own. The operator is more like the manager of the drone, tells it what to do, and then just monitors it and deals with air traffic control while the software handles all the flying. However, the most critical phase happens on the deck. This brings us back to that sailor with the gamepad that we mentioned earlier. These represent the deck handling operators. They stand on the flight deck alongside the traditional yellow shirt directors and use a deck control device, a handheld unit explicitly designed to feel familiar to a generation raised on Xbox and PlayStation. During the 2021 demonstrations, these operators used the device to taxi the drone, line it up on the catapult, and clear the landing area, all while dealing with the chaos of a live flight deck. It is a brilliant example of human-centric engineering. The Navy decided not to change the complex ballet of the flight deck. They kept the hand signals and the traffic patterns exactly the same, and they just built a robot that could fit into that ballet rather than forcing the humans to learn a new dance. Testing on the edge. Before the Stingray could prove itself on a carrier, it had to prove it could actually fly. Boeing built a contractor-owned demonstrator aircraft known as the T-1. In September 2019, T-1 took to the skies for the first time, not over the Pacific Ocean, but over mid-America, St. Louis Airport in Illinois. And there was something undeniably strange about the sight of this jagged gray naval asset banking over the flat cornfields of the Midwest. By 2020, the T-1 began flying with the aerial refueling storm, that big Cobham pod hanging under its wing, testing the aerodynamics to ensure that the extra drag wouldn't confuse the flight control software. But flying in circles is the easy bit. The real test came on the 4th of June 2021. This was the moment the entire program hinged on, the first ever unmanned aerial refueling of a crewed aircraft. The setup was simple but a bit scary. The T-1 drone extended its hose and drogue, trailing the basket in the slipstream. Behind it, a Navy F/A-18 Super Hornet edged closer, its refueling probe extended. Inside the Hornet's cockpit, the pilot's its refueling probe extended. This is a high-stakes game. If the drone misjudges its position by just a few feet, or if the software reacts badly to a sudden gust of turbulence, the basket can smash into the fighter's canopy, or worse, the two aircrafts can collide. But the robot held steady. The Hornet pilot maneuvered into the basket, the probe clicked home, and fuel began to flow. And with that, history was made. It proved that a machine could be trusted to hold station within fleet of a manned jet. Later that year, the MQ-25 repeated the feat with an E-2D Hawkeye and an F-35C, proving it all wasn't just a fluke. With the aerodynamics proven, it was time to go to the boat. In December 2021, the T-1 was craned aboard the USS George H.W. Bush. This brings us back to those deck trials that we saw at the beginning, but this time, it was about gathering hard data. Engineers needed to know how the drone sensors handled the wind over deck and the pitching motion of the ship. To help refine the software, the Navy didn't just use the drone, they used a King Air aircraft acting as a surrogate, flying approaches using the Joint Precise Landing System, or JPALS. They were teaching the software how to land on an aircraft carrier in the middle of the ocean. While the physical trials were happening, Boeing and the Navy were also running virtual simulations to test the next frontier, manned-unmanned teaming. They demonstrated a scenario where a Super Hornet pilot could use their existing data links to command the MQ-25 to deploy its drogue and refuel them. It's a glimpse into a very different future of warfare. Today, the pilot talks to a tanker pilot on the radio. Tomorrow, they're probably just going to click a button on their display and their tanker will dutifully trot over and top them up. Money, politics, and delays. Now, of course, no modern defense mega project would be complete without a section on spiraling costs and agonizing delays. You've been here before, you know how it works, and the MQ-25 Stingray is no exception. As of 2025, the official program of record calls for the Navy to buy 76 Stingrays, 67 operational aircraft, and 9 for testing and development. The total price tag for this fleet is estimated at roughly $15.9 billion. Doing the maths, that works out to an acquisition cost of around $209 million per aircraft, a number that includes its share of the research and development costs. To keep the lights on and the assembly line moving, the Navy requested just over $1 billion in the fiscal year 2026 budget alone, covering procurement and further research, including the first 3 low-rate initial production airframes. To put that unit cost in perspective, for the price of a single Stingray, you could buy a small fleet of high-end business jets. To be fair though, none of those business jets could launch off a nuclear carrier and refuel stealth fighters 500 miles out over a hostile ocean, so I guess it's not a brilliant comparison, but expensive it is. However, writing the check is kind of the easy part for the US military. Getting the aircraft is proving harder. Originally, the Navy hoped to have production representative aircraft flying by 2022. Nope, it is 2025. You're probably watching this in 2026, with initial operational capability, or IOC, following in 2024 or 2025. In a move that will surprise absolutely nobody who follows military procurement, the schedule has slipped repeatedly. A 2023 Department of Defense Inspector General audit flagged serious risks in the Navy's plan to start production before testing was actually finished, warning that this fly-before-you-buy approach could drive costs up and push delivery dates back. As of late 2023 and early 2024, the official schedule had pushed test flights to 2025 and operational readiness to 2026. But even that turned out to be optimistic. By late 2025, reports confirmed that the first flight of the Navy's production representative jet had slipped again into early 2026 as the team wrestled with structural tests and software certification. The target for actual combat readiness is now listed vaguely as by the end of fiscal year 2027. It's the usual dance of modern defense programs. But it has real consequences. Every year the Stingray is delayed is another year that Super Hornets are burning out their airframes, playing the role of flying gas tanks. So why? Why the holdup? Well, the Pentagon points to a perfect storm of issues. Design and build challenges, massive supply chain shocks caused by COVID, and broader quality and labor issues within Boeing's industrial base. We've heard that one before. To try and clear the bottleneck, Boeing opens a new $200 million dedicated facility at St. Louis Airport in 2024, designed specifically to churn out these drones. Naturally, this has all sparked a fierce political debate. Critics argue that the Navy could have solved the tanker problem much cheaper by simply modifying more FA-18s or even bringing the retired S-3 Viking out of the boneyard. They argue the Stingray is an incredibly expensive way to deliver fuel. But supporters counter that the fuel is just the appetizer. They argue the MQ-25 is a pathfinder. Its real value isn't just in gallons delivered, but in teaching the Navy how to integrate unmanned aircraft into the carrier air wing at scale. It is the entry fee for the future of naval warfare. Beyond the tanker. So right now, the Stingray is just a tanker. But if you talk to naval strategists, and especially if you look at what analysts are whispering about, it is very clear that tanker is kind of just the beginning here. The most immediate impact is range. The Royal Aeronautical Society notes that by offloading 15,000 pounds of fuel at 500 nautical miles from the carrier, the MQ-25 effectively doubles the combat radius of the air wing. This is the big metric that Chinese military planners are reportedly getting quite worried about. Think of it like this. Without the Stingray, the carrier has to park dangerously close to the enemy coast to launch airstrikes, basically right on the edge of the danger zone. With the Stingray, you're moving the gas station from the safe outskirts of town to halfway along a dangerous highway. Suddenly the fighters can top up their tanks deep in the combat zone, allowing them to strike targets that were previously untouchable, while the carrier stays hundreds of miles further back in safety. But the Stingray is a big aircraft with a lot of internal volume and long endurance, which makes it perfect for a secondary role, the sensor truck. The Navy's own documents explicitly list intelligence, surveillance, and reconnaissance, or ISR, as a secondary mission. Because it doesn't need a cockpit or life support, there's plenty of room inside for radar arrays, electronic warfare jammers, or heavy communications gear. Analysts envision the Stingray acting as a cell tower in the sky, orbiting silently for hours, linking manned fighters, ships, and other drones into a single network, relaying data back to the fleet while the fighters focus on the fighting. Then there's the spicy option, the missile truck. In 2024, photos surfaced of an MQ-25 model at a trade show. It wasn't just carrying fuel pods. Under its wings were two massive AGM-158C LRASM stealth anti-ship missiles, and under its nose was a new sensible. While the Navy hasn't officially committed to this armed Stingray configuration yet, the logic is pretty seductive. If you have a drone that can fly long distances and has low observable shaping, why not use it to launch long-range missiles? It could allow the carrier to launch salvos of stealthy anti-ship weapons from well outside the range of enemy defenses, turning the humble tanker into a lethal standoff striker. Ultimately, the MQ-25 is a pathfinder. Navy leaders are already talking about a future, perhaps by 2040, where up to 60% of the carrier air wing is unmanned. The Stingray, along with the mission control infrastructure, UAWC, being built into carriers right now, is the foundation for that future. It is the platform where the Navy will learn the hard lesson of how to operate humans and machines side by side. Now, the MQ-25 Stingray is kind of the definition of a boring mega project. Again, sorry about that. Thanks for sticking with us. I found this pretty interesting, to be honest. But it is also a quiet revolution. It doesn't have the supersonic glamour of a new fighter jet or the apocalyptic power of a strategic bomber. Instead, it just solves a fuel problem. By taking over the tanking mission, it turns one of the Navy's most expensive inefficiencies, burning out frontline fighters as improvised fuel trucks, into a job for a dedicated robot. In doing so, it potentially restores the long reach of the carrier strike group, pushing the kill radius of the air wing back out to where it was during the Cold War, but this time with modern stealth and networking. Perhaps more importantly, the Stingray forces the Navy to answer the terrifyingly practical questions of the future. How do you taxi a robot in 50-knot winds, in the dark, next to spinning jet intakes? How do you design the control rooms? How do you build a doctrine that lets a pilot trust a remote operator when things go wrong in the landing pattern? The MQ-25 is the machine that is forcing the Navy to write the textbook for unmanned aviation. If all goes to plan, kids born today will grow up in a world where the weirdest thing about an aircraft carrier won't be that jets are landing on a moving ship, but that half of those jets don't even have pilots. And when that happens, it'll be because the Navy started by teaching one humble flying gas station how to do it all. Thank you for watching.